Hey everyone, today we are going to talk about relations and functions. We're going to start our conversation about them. We'll talk about the differences between them and how you can tell when something is a function and when something is not a function. So I want to start with the idea of what a relation is. A relation is simply a set of ordered pairs, and it can be really anything. It can be just data that relates to each other. For example, your doctor might have a list of patient ages and their heights. A fast food place might have a list of different types of sandwiches that go with different types of drinks. It could be something that's not number related, but it can also be something that has to do with numbers. An ordered pair would be coordinates of a point. So say, for example, you have the point 3, 7. Okay, that is an ordered pair because 3 and 7 go together. Remember, when you plot a point, the first coordinate is your x value, the second coordinate is your y value. So that's an ordered pair. So when I refer to a set of ordered pairs, that means I'm putting a bunch of them together. So 1, 2, 1, 8, -5, 10, or something like that. Okay, that would be a set of ordered pairs. A function is a very special type of relation. And what makes something a function is this statement right here. Every x value corresponds to one and only one y value. So for example, if I have the point 3, 4, 3 corresponds to 4. If I have the point 8, 15, 8 corresponds to 15. So a function would be a set of ordered pairs where every x value corresponds to one and only one y value. I'm going to show you some examples of things that are functions and things that are not functions, and that way you can see the difference. Okay, on your paper, you should have your note sheet printed out here. If you don't have this done, printed and ready to go ahead and stop the video. And make sure you print it from the assignment so that you have this in front of you. You can follow along as we go. The problems on the left are not functions. They're just relations. The ones on the right are, in fact, functions. The first way we can represent data is with a list. So my set of ordered pairs are presented as a list. Okay. If you notice in the example on the left, let's look at our x values. We have 1, and then we have 2, and then we have 2 again. Over here on the right, I have 1, and then I have a 4, and then I have a 6. So if you notice here on the left, I have an x value that repeats. 2 comes up twice. Over here on the right, I do not have any repeating x values. So remember our definition of a function, that every x value corresponds to one and only one y value. That means that x cannot repeat within the set of ordered pairs. If you look over here at option 1, I have a repeating x value. 2 comes up twice. Over here, I have all different x values. No x values are repeating. Okay, that's what makes this a function and this one not a function. Whenever you see repeating x values, it's not a function. So if you want to write yourself a little note here, repeating x values means it's not a function. Okay, no repeating x values means it is a function. No repeating, that's a G there, no repeating x values. Because of the definition, every x value corresponds to one and only one y value. That's what makes it a function. So here, 2 corresponds to 3, but 2 also corresponds to 8. It's corresponding to more than one y value, so that cannot be a function. Let's look at example number 2. Now this is another way to represent your data. This is using a table. And you'll see here that I have repeating x values. 3 repeats and 4 repeats. So 3 corresponds to 4, but 3 also corresponds to -4. Because 3 is corresponding to more than one y value, it's not a function. If you look over here on the right, I have different x values, and all of my x's are corresponding to different y values. So -1 only corresponds to -5. 2 only corresponds to 4. 3 only corresponds to 7. 4 only corresponds to 10. So that is, in fact, a function. Okay, example number 3 is called a mapping diagram. Mapping diagram. And if you look at the one on the left here, this is not a function because, and the way that you can tell is by looking at the lines coming out of your x values. Okay, whenever you do a mapping diagram, your x's are on the left and your y's are on the right. And if you notice, -1 has a line going to 3 and a line going to 4. So -1 corresponds to 3 and it corresponds to 4. Because it corresponds to more than one y value, it's not a function. Okay, 1 corresponds to 1 and it also corresponds to 2. Again, it corresponds to more than one y value. 2 only corresponds to 3 and 4 only corresponds to 3. So, because of the -1 and the 1 corresponding to more than one value, that's not a function. If you look over here on the right, each of my x values only has one line coming out of it. Okay, so -2 is only corresponding to 4. 2 is only corresponding to 4. 4 is only corresponding to 16. 5 is only corresponding to 25. 6 is only corresponding to 36. So this is a function because each of my x values only corresponds to one y. And now people might say, wait a second, -2 and +2 are both going to 4. That doesn't matter. It doesn't matter if your y value repeats. It only matters if your x value repeats. If your x value repeats, it's not a function. So here my x value repeats. -1 repeats because it goes to 3 and it goes to 4. Here, none of my x's repeat because there's only one line coming out of each of them. Okay, our last example here would be a graph. So this is another way you can represent data. And the way that we determine whether or not something is a function when we're looking at a graph is that we do what we call the VLT, which is the vertical line test. And this is really neat. The vertical line test says this: if you draw a vertical line anywhere in the graph, if when you draw the line you intersect the graph more than one time, it's not a function. In this case, I drew a vertical line here and I intersected the graph twice. So that's not a function. Over here, I can draw a vertical line anywhere. It doesn't matter where I draw it. Every time I draw a vertical line, I only intersect the graph once. Here, I just have to be able to draw it through the graph in one spot and intersect more than twice. So some people might say, yeah, but if you draw a line over here, you don't intersect the graph at all. That's true, but if I can draw a vertical line anywhere and intersect it more than once, then it's not a function. And the reason is, again, because I have an x value that's repeating. right? If I draw a vertical line here, I have, when x is 0, I have a point here at 3, or I have a point down here at, looks like -5. Okay, so I have x values that repeat. So those are the different ways that you can determine whether or not you have a function. Again, if you have repeating x values, it's not a function. So that's what you're looking for in these problems. Your assignment is very similar to this. Okay, so if you need to refer back to this when you're doing your assignment, go ahead and do that. All I need for you to do on your assignment in the online Dropbox is type in if it's a function or not a function. Okay, everybody, I'll see you next time. Bye.